So, good morning, everybody. Morning, fantastic, thank you. Right, so I lost my laser pointer, by the way, so I've got a big long cable today, so hopefully that'll work and I won't trip over it. So just wait for me to trip over it and that'll be amusing. I've got some announcements. Please guys, if you could just settle, thanks. I've got some announcements, so coursework. Two announcements about coursework. Firstly, please, I tacked on an extra question to the coursework about a few days after I gave it away early. Okay, so there's like an extra question at the end worth 2%. Some of you went and downloaded it, like as soon as I released it, and have still got that copy. I noticed one person that in the lab the other day. So just make sure you've got the up-to-date copy of the coursework, that's the first thing. But I think all of you have, basically. The other thing is coursework marks. So I'm going to release the coursework marks next week, so in a few days. On Monday, the demonstrators will email me the marked scripts, basically. Then I've got to collate those into a spreadsheet. So as long as all the demonstrators have done what I've asked them to do, I'll be releasing the marks Tuesday, maybe. Okay? Go. Excuse me. Thanks. The other thing is the exam. So I've got a few people asking about the exam and what's going to be in it. So I'm going to basically dedicate half of next lecture to talking about the exam, and we'll go through an exam paper, and I'll tell you what we expect. I've also put the exam papers on the internet, so you can get the last two versions of the paper. Now, I've only been teaching this module for 2 years, which means there's only 2 past papers I've written myself. Now, I'm very happy to put the past papers up that the previous module convener wrote, but you must remember it was then a second-year module, and I didn't write the papers. So would you like me to put up I can put up 4 years of papers, but you must remember I didn't write 2 of them. So would you like me to do that? Okay, well, I'll put them up, but don't get scared by them, because they've got nothing to do with me, okay? But they might be handy. Oh yes, final announcement is C20 today. So numbers have dropped quite a lot, and I think there's only about half of you here. So that your colleagues in the 3rd and 4th year can get some extra computers, I'm going to try to shut C20 for the examples class. We're only going to be in the ESLC top floor and C19. If lots of people turn up and we can't fit in those 2 rooms, I'll open C20 again. So initially, you can go sit there if you want, but there won't be any demonstrators. So try and fit into C19 and the ESLC. Right, so with that said, let's crack on with this lecture. So this lecture is called, so it's lecture 9, Advanced Input and Output. So there's going to be a little bit of recapping this lecture because it's going to be based on some of the things we've learned earlier. So we're going to do a quick revision of parallel computing and functions just because we did those last lecture. And if you missed last lecture, please go and do the example sheet on functions, okay? Because it teaches you how to do functions, basically. You don't have to have been to last lecture to do the last example sheet. And functions are always in the exam, like always, always, always. Okay. So, and then we're going to look at revision of input and output, because that's what this whole lecture is about. And then we're going to look at some advanced input and output, and I'll show you how useful this is. And this lecture, I can't really sugarcoat like I sugarcoated some of the previous lectures, but what you are learning is you're learning something quite fundamental about how all computers read and write to files. And this isn't just a MATLAB thing. So many of the things I teach you in this lecture don't just relate to MATLAB, they relate to other languages too, that you may very well meet in your career. Right, so last lecture we learned about parallel adding, and we learned that, no? Just come sit down quickly, please. Thank you. Okay, we learned about basically parallel computing. And I taught you that effectively many modern chips, so here's an example of a chip, this isn't a modern chip, have parallel computational units. So they actually have hardware that can do multiple operations all at the same time. And this is an example of a parallel adding unit. And the advantage of that is that computers can perform lots of operations all at once rather than doing them in like a queue. So until last lecture, if I asked you to add all these numbers together here, so 1, 1 plus 1, 2 plus 2, 2 plus 4, 4 plus 7 plus 7 plus 1 plus 2 plus 3 plus 3 plus 1, you'd have done it like that. And what MATLAB would have done is it would have used its chip, so that it would have used the CPU of the computer, and it would have started executing these lines, one after the other, after the other, stupid thing. I think Yeah, one after the other, after the other, after the other. And I said last lecture, if you put your mathematical operations in a matrix, then MATLAB realizes very, very quickly that, oh, I can do all these operations at the same time, and I can use my parallel hardware. So as soon as you start to do matrix operations like this, the computer instantaneously thinks, oh, I can use this very fast parallel hardware, and your maths is accelerated. And there's an example in the coursework, and I think people are getting speeds up of about 10 or so by doing matrix operations. I also taught you the tick and the tock commands that are used to time mathematical operations, and these are very useful when debugging code. So when you start writing serious code, knowing how long your code takes to execute is very important. And if you can shave 1%, 2% off a loop, then that can equate to hours of speed up of your code. We then looked at functions, and functions are incredibly useful because effectively you can encapsulate a command or an algorithm or something like that into a little box, and you can use this box, this function, again and again and again. So we call a function like this. So we made a function last lecture that calculated the average of 4 numbers. Functions can literally do anything you want, but our example is calculating the average of 4 numbers. And we made our function called our function, and we passed it the numbers 1, 2, 3, and 4, and it returned a single number that was the average of these 4 numbers. And functions, we learned functions always start with the word function, always end with the word end, and whatever code you want to embed in the function, you put between the function and the end. And effectively, your numbers go in here, so your A, B, C, and D all go in here. And the output is calculated, well, this is the output number, the output variable. We just set it here as the answer, and it sort of instantly gets transmitted back to our main code, and we can get the answer out there. And this is something you've got to practice. It takes a little bit of practice. So just go through that example sheet, and it really is a noddy's guide to functions. And once you've done that, it's not that difficult. You can do it. Now, I now want to revise input and output, because this whole lecture is about input and output, and it's very important that we've got this in the forefront of our minds. So this is a bit sort of interactive. So what's the name of the command you'd use to get data from the keyboard? Input. Thank you very much. You've got to be interactive. Thank you very much, whoever shouted that out. Okay, so here's an example. Now, I noticed quite a few people making this mistake in the, just going to swap hands, making this mistake in the lab. So they wanted to get some text in from the keyboard, and they typed input, what is your name? And they forgot this single quote, S, single quote. And what this S stands for is string. So what this tells the computer is, I want some text in, so I want a string. So a string is the computer word for a text. Please read in a string. And if you put this S, then it will read in actual text, so your name, or where you live, or what city you live in. If you don't put this S like this, then MATLAB expects you to enter a number, so like 1 or 10 or 17 or your age or something like that. So this is reading a string, and this is reading a number. So what 2 commands could you use to write to the screen? Disp, and what else? Fprintf, right, exactly. So those are the 2 I've taught you so far. So disp, very simple. We go disp, hello, my name is Rod, prints the screen, no problem at all. Fprintf, now, when I taught you this, you might have thought, this is a bit of a pain to learn about. You might have thought, why are we learning how to print like poetry on the screen and nicely formatted text and stuff like that? And why should we bother so much? Because we're not interested in designing graphical interfaces, that's for computer programmers. Well, I sort of justified it by saying sort of all the interesting computers you're going to program, like flight management computers and stuff like that, only have rubbish screens, and effectively you need to be able to print out on tiny little dot matrix screens what's going on. And that was a very fair justification of why we should learn about Fprintf and nice text formatting. But there's another reason why I wanted to learn about Fprintf, is because there's lots of commands in MATLAB that use this same sort of format. So in that you effectively write, or you specify your format here, and then you put your variables here, and it'll sort of combine them. And this whole lecture is going to be on those, and now you've got Fprintf, you can basically do these other commands very easily. So Fprintf is basically string formatting. So if we wanted to print out, my name is, so Rod, and I live at flat number 9. So what MATLAB would do is it would go, oh, Fprintf, okay, my name is %s, okay, %s, that means a string. I need to go and get the string from the end and pop it there. And I live at flat number %d. It goes, oh, %d, I've now got to go and get the 9 from the end and pop it there. And then once it's sort of built this string using this format and what's at the end, so the variables at the end, it stores it in A, and then you're ready to display it with the disp command. And these percent things are called format specifiers. And there's a whole bunch of these. So I used here %d. This is for a decimal number. There's also scientific notation and things like that. So, for example, if we wanted to print pi to different decimal places, we could do it like this. So we could go out equals fprintf. The value of pi is %.5f. So this is pi to 5 decimal places, %.10f, pi to 10 decimal places. And very good. Now then, this is where we start to build on what we learned previously. So there's another command called fprintf. Okay, so can you see this is sprintf and this is fprintf. Now the difference between these commands is sprintf effectively saves the string it's built to this variable out, whereas fprintf just prints it directly to the screen. So you don't need to use the disp command. So it's like a one-line command for displaying text to the screen. Okay, you might think, so what? I'm just going to get rid of my mouse. Or maybe if I don't hold it like that. Right, so we're now going to build on this. So, what's the command to load data from a disk? Load, right? Easy, I gave you the answer. So far, if, for example, I gave you a data file that contained this matrix, you could use that load command, and you could load that matrix into an array. And that's about as far as we've got in terms of reading in files. Okay? This is one thing I'm just going to talk about in a little bit more detail. So if, for example, this was stored in a file, data.dat, and I said, please plot one column against another column, you could do it like this. So this is a typical exam fodder. You could do it like this. So, question, please plot one column against another column. So firstly, we clear the memory, then we load the data file in using the load command, and this loads this whole thing into a matrix called my data. Now this is a question. The demonstrators said that you all got quite a little bit wrong, or some of you got wrong in the coursework. So the size command doesn't just return a number, it returns an array, okay? So if you've got a 1D array, just like that, one big array like that, the size command will return, we'll call it x, will return the length of the array, x, okay? If you've got a 2D array, so you've got like that and like that, so a grid of numbers, like you've been processing, the size command will return in the array the x and the y. Okay. Now we haven't done 3D arrays yet, but if you had a 3D array, so imagine like a box, okay, the size command would return x, y, z. So the point is the size command returns an array, not just a single piece of data. So what this means is, whenever we use the size command, we've got to pluck out of the array len which one of these x or y, or x, y, and z we want to use. If it's a 1D array, it doesn't matter so much. But as soon as you start to get 2D arrays, you need to select whether you want the x length, the y length, or the z length. Okay. And then we just extract extract one column, extract the other column, and plot the data against each other. And I won't go through those exactly now because you can look it up in the last lecture. And you can copy and paste that and play with it if you want. So we're now going to finish off this very basic input and output. So what command would you use to save data? You don't know this yet. What command would you use to save data to a disk? Can you guess? Save. Very well guessed. Okay. So it is in fact the save command. So if I made a random matrix of 5 by 5 like that, this is how I'd save it. I'd go save hello.txt, so that's where I want to save it. Then I'd go A, that's the matrix, and then I'd use this. I'd have to put bar ASCII II. Now what that tells MATLAB is it says, please save this file to disk in a format that humans can read. Okay? If you don't put this, if you don't put ASCII II, MATLAB saves it in a format that only computers can read. So it's like a binary, compressed, crazy format. It's a bit like a zip file. So if you want to be able to read the matrix, just put ASCII II. So that's like just one useful command that I want to tell you. We've now finished off basic input and output. So you've got the load command and the save command. I'm now going to show you where the load and the save command fail to work, because they do fail to work, or where you can't use them. So until now, we've been able to read in nicely formatted matrices like this. But very often in computing, you don't get a nicely formatted matrix. So you might be processing data from some piece of kit, and the data it gives you is in some crazy format that you've got to read very, very carefully, and it's not in some nice matrix. And I promise you, so I'm not quite sure what's on the next slide, but pictures, do it? No. Okay, so I promise you, as soon as you start to interact with bits of kit, so oscilloscopes, voltmeters, because they all these days have computer interfaces, they will, so any piece of kit you try and interact with, they will spit out data in some crazy format that is not nice at all, and it will have letters in it, it will have numbers, it'll have ASCII characters that you can't read very easily. So here's an example that I've made up that's got some data in it that's not very nice. So imagine you've got this weather buoy. Okay, so this is sitting somewhere in the channel or just off London, and it spits out this data, and it saves this data to disk. So it goes London, 27th of 11th, 2013. What's that going to be? A time, maybe? So that's maybe a temperature. This is maybe humidity. And this is maybe pressure. So you can see it's recording to disk, basically, location, date, time, temperature. It looks quite cold and rainy. Humidity, pressure. And then it does it again, then it does it again, then it does it again, and does it again. So this is actually quite a nicely formatted file, but you still wouldn't be able to read this with a load or save command. So we won't bother guessing what these lines mean, because I've just told you. So here's what they mean. So if you're a computer programmer, and very often you have somebody gives you some data, like from say, in-flight data recorder has been recording data or something, and somebody says, here's some data, please process it for me. You couldn't do this with a load and save command at the moment. So we need sort of a little bit more control over the input and output of files. And here are some examples of things, obviously, that might spit out crazy data. So this oscilloscope, for example, if it had a digital output, it might spit out some crazy data. If you're trying to get some data off an accelerometer or something like that, it wouldn't give you nicely formatted data. So without labouring the point, we do need more control over files. Now, what I'm teaching you now is fundamental to how computers handle files. This isn't just some MATLAB thing where I'm just teaching about MATLAB. This is how all computers handle files. So in my pocket I've got a phone. This handles files the same way. It's like absolutely in the low level of the operating system. Your Windows computer handles files the same way. That projector thing that just crashed handles files the same way. So what you're learning here is very fundamental to how computers handle files. So this is how it works. So I've got some lecture notes, here we go. This is my example. So then, this is how it works. To open a file, so if this is a file here, okay, what you've got to do is you firstly got to open the file. Okay, this might seem really obvious. So open the file. Then you can read the file or you can write the file. Okay, and when you're finished, you must close the file. Okay, so this always this process. So open the file, read or write, close the file. Now, the reason I'm sort of labouring this point is because computers, so any device, will have a maximum limit of files it can have open at any one time. So for a modern PC, it might be, I don't know, it might be 1 million or something. But if you don't close the file, then at some point you'll have 1 million open files and it won't be able to open any more. And if you try and read a file without opening it, it will also complain, it just won't work. So you must always do this process religiously. Open, read, close. Or open, write, close. It's always that process, no matter what computer you're on. So, what we're going to do now is I'm going to take you through reading and writing to files using a sort of more advanced input and output commands. Right, I think I've laboured that point. So, let's look at how we do this in MATLAB, and I'll show you later how transferable this is. So firstly, we're going to open the file. So we're going to be reading the file data.dat, okay? Data.dat. What we're going to do is first we're going to open the file. And to open the file, we use the fopen command. So that's file open, okay? And if we want to write the file, can you see there's this file name, then a W in single quotes? That means write, okay? And there's various modes of operation for a file that we'll learn about in a minute. So there's write, and when you write to a file, always write starting at the beginning. So it always deletes the file and then starts at the beginning. If you append a file, so with an A, it'll write code at the bottom of the file, and if you have an R, it'll read from the file. So whenever you open a file, use the fopen command. Okay. Now, this is important. This is like fundamental to about files. Every time you open a file, so every time you go like bloop and open it, the computer goes, oh good, I've opened a file for you. Now, here is a number that you can use to reference this file. So whenever you open a file like that, the computer gives you a number. Okay, it could be 1, it could be 3, and that number always refers to just that file. Okay, and whenever you want to do anything with that file, you must give the computer that number. Okay, so whenever you read, open, write, close, you must always use that number that the computer's given you from the fopen command. Right. So, for example, if we go file fopen 1.dat, and then we look at what the file number is that fopen's returned, it could give us a 3. Or if we look at what fopen returns when we open the file 2.dat, it could give us a 2, it could give us a 7, for example, or when we look at the number that fopen returns when we open a different file, it could be a 1. So the point is the number it gives you is random. It's totally random. But what the computer does promise you is that this number it gives you will be unique. It'll be your number that you can always access that file with. Okay? And this is called, well, there's lots of names for it. But you can think of it like a file ID or like a reference number for that file. Okay. So the next step is writing to the file. Right? So we've opened the file. So imagine it as a book. Open. We've got our number. Okay. Now, do you remember I just taught you the fprintf command? Okay. Go fprintf. The value of pi is %.5 %.10f pi. And this will print to the screen. The value of pi is 3.14159, blah, 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 blah. Now, this is the key point. fopen has just given us a number. Okay, it's just, and we've saved this in a variable, file 1 or file 2 or data file. Now, we use this number with the fprintf command. So if we want fprintf rather than to print to the screen, so this is printing to the screen, all we do is we go fprintf, then our file ID that the computer's just given us, so that we put our variable with the file ID. Then we just use the fprintf command like normal. The value of pi is blah, 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 blah. And this will write to the file, referenced by file ID. The value of pi is 3.14159, etc., blah, blah, blah. So this file ID is very powerful. We've just used it now to write to the file. Okay. Any questions so far? Please shout out, because I realise this is a bit tricky. Okay, what we're going to do next, can you guess what the next step is? Close the file, I heard murmured. Okay, very good. So, closing the file is easy. Super easy. We just go fclose for file close, and there's literally, so we've got an open book, and this just closes it. So, whoops, yeah, so now, whoops. So now this is our entire program, okay, starting from the beginning. So we open the file with this W for writing. We go fprint, and we get returned this file ID. We then go fprintf file ID. So this is the ID that we know references this file. Write this text to it and close the file. That is how you write to a file, okay? That is always how you write to a file. Now, let's watch this in practice. If I can... boom. Okay, so there we've got our text. So file ID, fprintf, and file close. So open, write, close, okay? And we just run it, and it saves this to the file. Or I think we can now change this fprintf statement. So we just changed it a bit, run it again. Let's open the file. We've written that to file. So this is very powerful, because what you can do also is when a program's not working, you can just save the output to a disk and just troll through it later and find out why it's not working without having to save it all to the screen. So now we can change this. My name is Rod, and it prints my name is Rod to the file. So this is very powerful now, because we can write anything we want to a file. Okay? So we open it, we get its file ID, we use fprintf, we then close it. Any questions? I'll stop that. Any questions at all? Please shout. I'm really happy to answer questions. No? Okay? Great. So where are we? don't even know. Oh, that's not even my desktop. What? Oh, I see what's happened. Presentation. Right. So, it's your turn. So what I'd like you to do is I'd like you to write out on some paper, I'd like you to write a script to save your name to disk, and then I'd like you to write a script to save your name and your age to disk. So you're going to be using fopen, fprintf, and fclose. So you can look back through the notes and just do it as quickly as possible. And I've got like 5 chocolate brownies for people who are quick. So do try and do it because you'll remember it, and this is absolutely exam fodder. So fopen, fprintf, and fclose in that order. Yes. Yes.
If I were to write text into like a certain file,
Yes.
like if I wrote close,
Yes. Yeah.
if I want to go to next line,
Do that later. We'll do it later. It's a bit complicated, so we'll do it step by step. Very good question, but okay. Put your hand up when you're done. Nobody's done yet? Pop your hand up when you're done. 2 lines there, looking good. 2 lines, very good. It's all looking good so far. Pop your hand up when you're, oh, you're right over there. There's nobody here that's done it, is there? You're asleep. Have you done it? No, not yet. It's a bit long, this one. Oh, come on, nobody's done it. I've got to go all over there. Who was it with a hand? Is it you? Yeah? Let's have a look. Right, let's have a look. Just hold it up. You haven't even finished. No. Sorry. Everybody got it? Yeah, there's one. Excellent. Let's have a look. Hurry up. Absolutely spot on. That's the first one. Okay, so have a go with the second one now. You have one of these anyway to be going with. Quick. Whoop. Oh, I'm sorry. That'll do, won't it? Oh, right in the middle. Let's have a look. No. What have you forgotten? Fclose. Yeah? You haven't closed it? Yes, that's much more like it. Yeah. There you go. Okay, I'll give you another couple of minutes because I want to move on. Yeah, let's have a look at you. Good stuff, yeah? Nobody's doing the second question, so it's fine. I don't mind. Yeah? Where was it? How are you doing? Are you doing here? You don't get it? Oh, do you want me to go through it again? I'll go through it again. Excellent. Okay. Yeah, very good. Have one then. Okay. All right. Who would like me to go through stuff again? Because there's a guy there who says, or one person here says he didn't get it. Would you like me to go through it again? Or have you done it? Quickly. All right. Right, so, right, we're going to go through this again, but like, guys, we're going to go through this again, but like at warp speed, okay? Because we've got to go on to the next example. So, opening file, you've got to open the file, you can then read or write to the file, you can then close the file. These are the 3 things you must do when dealing with files on computer, okay? So it's open, write, close, or open, read, close. When you open a file, the computer will give you a number. It will return to you a number. This number is a unique number that just references that file when it is open, okay? When you close the file, the number goes, and the computer uses it for something else, okay? To open a file, we use the fopen command, okay? So what happens is we go fopen data.dat w for write. So this opens the file data.dat in writing mode and returns the variable, returns the number which references that file in file ID. Okay? And here's some various examples. Now we need to write to the file. To write to the file, we use fprintf, okay? To tell fprintf which file we write to, we need to use the file ID variable, so the number that references the file that's open. Okay? Then, once we finish writing to the file, we need to close it using the fclose command. That's it. fopen, fprintf, fclose. Does that answer the question? Guy answered the question. Yeah, happy? Anybody else got a burning question? Okay? All right. So I take this is one of the more difficult concepts, and it's not just like learning one thing. It's learning sort of a progression of things. But it is really well worth learning. That's why I teach it to you. Right. So what we're going to do now is we're going to read from a file. This is like exactly the same process, but just one or two commands change, and it'll be pretty obvious. Okay. So once you've got the hang of writing, reading's easy. So what command will we use to open the file? Fopen, same command. So, I can't talk over you. Okay, so, this time we're opening the file for reading. We go fopen, data.dat, R. So R is to open it in a reading mode. Guy at the back in the white t-shirt, I can't talk over you. Yeah, you, with the glasses. Yeah, you, please, thank you. Okay, so this is opening the file. So we go fopen, name of the file, and then we're opening it in reading mode. And then again, we return this file ID. And this number in file ID always refers to the file that is open. Okay? Then, we need to read it. So you don't know the command to read yet from a file. I will now teach this to you. Reading from a file is called the command you use is fscanf. Okay? And this is how it works. So the file ID is here. This is a number that you've got from fopen. This then specifies the format that you'd like to read the file in. So this %s says, I would like to read a string. I'd like to read some text. And this 1 specifies how many elements you'd like to read. So if you've got lots of names, if you've got like Rod and Fred and Bob and James, you could put like 5 in there or something, and it would read 5 elements from the file. But we're just going to read 1 element because that will keep things nice and simple. And it returns the text in my text. Okay, that was quite simple. What are we going to do now, after we finish reading from the file? Close, exactly, thanks for shouting out. We're going to close it, and you know this command already. So we're going to close the file, fclose. So let's put it all together. So we've done all these 3 steps. Let's put it all together. fopen to open the file, name of the file, R for reading, and this will return a file ID, so the number that the computer gives us to use to reference that file. We then use this variable file ID in fscanf, and we go, fscanf, I'd like to read from the file referenced by file ID, %s, so for a string, 1 element, so just like my name or your name or something, and we're going to store this in my text. We're then going to print out, using the disp command, my text, and then we're going to close the file. That's it. So we can now read and write to files in any format we like. So I'm now going to show you a video of this. So here's the text. So here's the program. So open the file, read from the file, display the text, close. And that's the file there, by the way, data.dat. So we're going to run it, and it says hello. And we've got hello in the file. Now we're going to edit the file, save it, run it. It reads hello in from the file. Change it a bit more. Hi. Close it, run it, reads in hi. So you can see now we can read basically any text we want from any file in any format. So this is incredibly useful, as I say, because now basically you can interact with any data that's thrown at you. So whether it's from a data acquisition system, or from car airbag system, anything, you can interact with that data. Right. So I'm a bit of a funny angle here. Presentation. Okay, what's next? Right, any questions on that so far? No? All right, so that's reading per file. Now, we're going to look at a more complex example. So if you remember that example of the weather station, where we had that very long, complicated data stream, we're now going to use fopen, fclose, and fwrite to basically read from that file and process it for us. So this is a real-world example. So here we've got our data stream. We've got London, so text. We're going to read this in as text because dates are just complicated because they've got slashes. Number, text, number. So we're now going to write a program to read this file. So firstly, as with all complex tasks, what I suggest you do is break it down. So this is the thing with all computing programs. If you've got a complicated problem, break it down into small, easy bits. So what we're going to do to kick off with is rather than try to write a program to read this whole data file, we're just going to write a program to read the first basically record. So the first 1, 2, 3, 4, 5, 6. The first 6 lines. Okay. So let's break this down into even easier tasks. So rather than trying to read the first 6 lines to start with, let's just try and read the first line. And this is what I suggest you do when programming. When you're faced with a difficult task, just say, oh, it's difficult. I'll just do a little bit first. So a little bit we can do. We can go fopen, read the location. So this is the text. So fscanf file ID, which we get from this fopen. %f is a string. 1 is the number. 1 is how many elements you want to read. And let's close it. So we open the file. We've read the first line. We've closed it. It doesn't get anywhere near completing our task, but it's at least a little bit on the way. Okay. And incidentally, in the exam, if I ask you something really complicated and you just wrote that down, you get some marks for that because you showed you got on the way. Okay. So there's some comments. So now let's extend this program. Let's make this program a little bit longer so it reads every element in our file. So what we're going to do is we're going to go open the file. So we get the file ID. We read in the location. So that's what we had in the last slide. Okay. And notice the %s because it's a string. This is text. London is text. Okay. Then we go incidentally, the date. We're going to read the date in as text. Okay. We're not going to treat it as a number because it's got those backslashes in it and stuff, and that's a bit complicated to deal with. So let's read in the date as text. So we've got %f. Now we get to the first number. So let's go down. Let's go back. So we get to this 17. So that's the time, 1700 hours. So that's 5 o'clock. So we now read the time in with the next fscanf command with this %f operator. Then we read the temperature in, so we go fscanf file ID %f says please read in a floating point number and stores it in temp. Now I read the humidity in again with this %f, which reads in a number. Then we read in the pressure with this %f again because it's a number, and then we close the file. So this is sort of read in the first 1, 2, 3, 4, 5, 6 elements of our file quite easily, and you could do this now. Okay. So let's just watch a video of that. So here's our file that I've made up. So we got London, oh crikey, London, date, time, etc., etc. Then the next record begins, next record, next record. So we're just going to read in the first record. So we're just going to read in that. There's the next one. We're not going to read that in. And there's the next one. We're not going to read that in. And where's our code? Here's our code, okay. So we've been through that already, so we'll just run it. When I decide to run it, boom, run it. And if you notice, what I've done is I put semicolons here, so it's not actually going to print out the output because we're suppressing the output. But when we type in the names of the variables that we've stored it in, so when we type in location, date, time, temp, it'll be able to print them out for us. So location, London, time 17, temperature 5. So you see, this program has now read in all of our data stored in datafile.dat and stored it in these variables here, etc., etc., etc. Okay. Any questions on that? Yes, fantastic. How does it know? So the question is, how does it know which one's the pressure, which one's the date? It doesn't. We've told it. So I'll just go back. So the question is, how does it know which one's a pressure, which one's a date? Well, we know which order the file comes in, okay, because we know it's like location, time, pressure. We know the order, okay. So what we've done is we've ordered our fprintf commands in the correct order with the correct variable. So we know the first element is always location, so we always store that in location. Does that make sense? Okay, thank you for the question. Fantastic. Okay, any other questions? Yes? Yeah, it's difficult. No, I'm not joking. I'm just seeing how much time I've got left. Oh, not much. Yeah, it's difficult. You'd have to write some clever algorithm to figure out, is it text? Is it not text? Could this be the location? This is a city. Okay, it's text, and maybe check this against some city names. Do I know the city? Then it's the city name. So you have to write some intelligent algorithm. Yeah? Okay. Right, so we're actually quite short of time. So we're going to move on. Right, so what we've not done is, well, what we've done is only read the first element of the file, okay? So if you notice, the file's full of these records. It's got lots of records taken each hour. So what we've got to do is read them all in. And what we do to do that is we use a loop. So we put this code in a loop. And notice, we open the file outside the loop, and we close the file outside the loop. Because this reads like line 1, line 2, line 3, line 4, line 5, line 6. Then we go back up to the beginning, it reads line 7, line 8, line 10, etc., etc. So every time we call fprintf, it reads the next line, okay? But when we call fopen, it basically resets that. So you're back to reading line 1. So you've got to have your fopen and your file close outside the loop. Otherwise, it will just continually read in the first, second, third, fourth, fifth, sixth, seventh element. Now, what's wrong with this program? What's wrong with... Huh? It's a single... Oh, it does. Can you see that while? Can you see that 1? That means basically run forever. Yeah? So what this will do is it will literally run forever and ever. So what's wrong with that? Yeah, what happens if the file doesn't run forever? The file won't run forever. It'll have a limited number of elements in it. Yes, so the problem, we need to somehow detect when the file has come to an end. So we use the feof command. Now this is a bit of a weird command. This is probably the most difficult command we'll be using today, or we'll be learning today. And what it means is F for file, and then EOF means end of file. Okay, so this return a 1 or a 0, depending on whether or not we've reached the end of the file. So feof, file, end of file. It tells you always, have we reached the end of the file? Have we not reached the end of the file? Okay. So what this command will do is it return a 1 if it's at the end of the file, and it return a 0 if it's not at the end of the file. Okay. So what we do is we pop this feof command in the while loop, and we say while feof, and notice here we've got this file ID again, okay? And this always refers to just this file. So if feof equals 0, it'll keep running forever, okay? And when feof goes to 1, then we've reached the end of the file. Now, I say this, really go and practice this. This isn't something, as you might guess, there's quite a few steps. This isn't something that you can be good at just by listening to me. Go to the lab, practice this, use the example sheets, practice, copy and paste these examples into a MATLAB and try it, okay? That's the only way you're going to get good at it. So, let's watch the final video of using the feof command. Okay, so I've actually used so here's the feof command. I've actually used a not here. So this is, we haven't covered this yet, but basically just try and copy and paste this line and see what happens. But this will effectively run until the file gets to the end. So we click run. And then we can go display, for example, time. So we run this, it'll go time 17, 18, 19, 20, because that's what's stored in the file. Or disp temp, for example. It'll display the time and the temperature. So this is giving us really quite accurate output from the file. So now when we look at what's in the file, 17, 5 degrees, 18, 4 degrees, 19, 3 degrees. So you could imagine now, for example, building these into array and then plotting the graphs or something like that. So you can now really, with pinpoint, pick out different aspects or different lines of a file. Okay. Yeah, so the final thing, this is like the cherry on the cake, right? This is just sort of to go that step further. We can open files for reading and for writing at the same time. So here we've got file ID, this is our input, and here we've opened another file called file out. And you see here we've opened this with a W that means write. So we've opened a file here, there's an R missing. Now we've opened this one here for reading, this one here for writing. So what we can now do is we can use the fprintf and fscanf commands together. So we can read something from one file and write it out to another file. So here, this is the file for reading. Read all these files, read all this data in from one file, and then print some data, so time and temperature, out to a different file. So that's as complicated as it gets. Yeah, so I just want to show you one more thing. I hope. Now then, we're almost done. Oh, it's so slow today. When it starts. There we go. Right. So this is not MATLAB, okay? This is a different language. This is not what you're learning now. But I want to show you how powerful in general what I've just taught you is. What does this do? What does this program do? Just try and guess. It's not MATLAB. I heard one answer there. Can somebody give me an answer at the back? What do you think it does, generally? What was the answer there I heard? Reads, exactly. It reads something, okay? Now, I'm not trying to confuse you by showing this, but just what I want to show you, so this programming language is called C, okay? Now, C is used to program computers, so it's used to write Windows, it's used to write code for supercomputers. It's like the most powerful language ever, okay? But look at the commands that you recognize from this language that you don't know. You recognize the fopen command, you recognize the fscanf command, you recognize the fprintf command, and you recognize the fclose command. And you also recognize that this is the file ID, this is the file ID. So my point I'm trying to make to you is that what I've just taught you in the last hour isn't just like a MATLAB thing. This is like a universal way computers read and write to files. And no matter what language you learn in the future, so like PHP for web programming, C for computers, you will use this, what I've just taught you, even if you have to learn a slightly different language later. So this is how useful in general this is. That's it. So thank you very much for your attention. And now off the labs. And have a go at this, as ever. Just have a little go with files, and you'll be good at it. Thanks very much.